Okay, for this one, still modeling with quadratic equations or functions. Write a quadratic function to represent the area of the rectangle, only one. Graph the function, which we're going to sketch. Interpret the vertex and intercepts and identify a reasonable domain and range. Okay, so it's a fairly lengthy list of things to do. I'm going to move fairly quickly on this. On any of these problems, if I move too quickly or if it's something you're having a particular hard time with, just let me know and I'll go through more slowly and more detail. We're looking for the area based off of our x. Area is length times width, so we're going to do 2x minus 1 times x plus 5, and that gives us 2x squared plus 10x minus 1x, so that's plus 9x minus 5. And there's our model. Okay, there's our function. We can plug in any x value, and any x value we plug in will give us the area of this rectangle. Okay, we want to graph the function. I'm just going to sketch the graph of the function, and I'm going to use my tools of finding the vertex and the axis of symmetry and things. My y-intercept is at -5, so I'm going to put right here, I'm going to put a -5. And my y-intercept's right around there. And then my vertex, I'm just going to do -9 over 2 times 2 is 4. So that's positive. So this is at -2.25, so 2.25, -2.25, which we'll say is right about here, -2.25. And then our y value would be -81 over 8 minus 5. And that's going to be, that's a 0.125. Should be -15.125. Yes. Okay. 81 divided by 8 is 10.125. So it's negative 10.125 minus 5. So -15.125. This might have even been the one that we had on our test. So -15.125, I'm going to say is right here. And so my vertex, if I trace this line down, is right here, and across is right here. So here's my vertex. I know I'm going to cross at -5, and my parabola is going to go kind of like that. That's not a very pretty line. There we go. So something like that, and it's symmetrical, so it should go up at the same rate on this side. Obviously not ideal. Graphing calculator or Desmos would be good to actually graph it, but we're just going to go off the sketch. Interpret the vertex. Okay, the vertex, this right here, that would be the absolute minimum amount of area. You'll notice though that the minimum amount of area possible is a negative number, and at least as far as has been invented so far, we're not able to have negative areas. That would be really strange. Something to think about, I guess, negative areas. So we can't have negative areas, but that doesn't really tell us a whole lot. We know that the x values cross from negative to positive, and when they do, so at zero at our y-intercept, so if x equals 0, our area is -5. So again, not terribly useful information because we can't have a negative area. This point right here, which we haven't learned how to solve yet, that comes in the next chapter, but figure out this area, this point right here. Also this point right here, notice that if we go past this point right here, this area is positive. Yay, positive area. It's something that we can have. The problem is our x value is negative. And so if our x value is negative, we can't really, that doesn't make sense. Each side would have to be negative because a negative times a negative is a positive. And so we'd have a positive area with negative side lengths, and you also can't do that. So this point right here, the blue arrow over on the right, that is the one where we go from 0 area to actually having positive area. And so everything else on the graph is more or less useless. We can solve for that intercept, but we don't have those tools yet. So we'll wait until we get those. If you're curious, it's when x has, well, x is equal to 0.5 when it crosses. So it does ask to identify a reasonable domain and range. You don't have any way of seeing this 0.5. I guess if you use Desmos, you could figure it out. But x would have to be greater than 0.5 for the domain really to make any sense. Okay, anything less than 0.5 or even 0.5 gives us an area of 0. That doesn't make a whole lot of sense. Anything greater than 0.5, anything greater than 0.5 will give us some area. Okay, the bigger it gets after that, the greater our area becomes. And then for range, yes, we can go all the way down to negative 15.25, but really our range has to be, it doesn't make sense to have an area, and since our range represents our area, it should be greater than 0. That's what makes sense. So there's your reasonable domain and range. And this video is too long.